Good morning. Welcome at this last plenary session of this conference. This is a session that is going to be presented by Professor Sergio Savaresi from the Polytechnic of Milan. Sergio is a personality in Italy for his work in control and robotics and autonomous driving. So Sergio has a PhD in control engineering. He spent several years both consulting McKinsey Group and in visiting universities throughout the world. He's been then leading a group at Politecnico di Milano who has reached very important results. He's one of the most prolific authors in Italian academia, at least in our sector. He's not accomplished as a research scientist. He's also an entrepreneur. He started a number of companies. He started a company that starts companies. That's Innovia, that many of you will know. And most recently, his work on autonomous race car driving has reached great successes and a lot of visibility in it. So it is a big pleasure to have Sergio with us. Let's thank him for accepting the invitation and listen to him.
Thanks, Antonio, for the very kind introduction. So the bottom line is that I do too many things, and my wife complains a lot. That's the key point. First of all, I would like to thank the organizers for inviting me to give this speech. Let me anticipate that my presentation is not going to be deeply technical, so let me anticipate a possible delusion. So I apologize for being, let's say, really high level. The main point of my presentation is to give you a general perspective of what is expected in the future. I'm talking about 20, 30 years ahead in the personal mobility. And the key concept I would like to share with you, to discuss with you, is that the robotization of the car, let's call them Robo-driver or AI driver or autonomous car, but probably Robo-driver is the right word, is going to be the enabler of this mobility revolution. We're going to face a revolution, and this is the key technology that will enable this revolution. This is the key message that I want to share with you and to discuss with you. Okay, let me start from a really high level. In this slide, you can find something which is the problem of the human race in the future, let me say, in short. In a very simplified way, we can say that we've burnt fossil fuel for an equivalent of 2,000 gigatons of CO2, and according to that, we increased the temperature, the average temperature on the Earth, of the planet, of 1 degree. There is a general agreement that we have to stay below plus 2 degrees with respect to the, let's say, pre-industrial era. And so we can simply say that the human race has a budget, has a residual budget that can be quantified in another approximately 2,000 gigatons of CO2 by burning fossil fuel. The scary thing, the very bad news, is that this amount, this residual budget, is less than 5% of the equivalent CO2 of what is underground. So it's a really tiny amount of the fossil fuel that, in principle, we can burn. So the key point, the key challenge for the human race will be to keep underground the largest part of the fossil fuel. Who is responsible for these 2,000 gigatons of CO2? You can see that's the cumulative, roughly speaking, 1/3 North America, 1/3 Europe, 1/3 Asia. This is for the past, for the cumulative. Emission today, you can see here the split, the biggest emission producer is China, not surprisingly, but the real deadlock is not, let's say, the discussion about the total and the per capita emission. If you see the per capita emission, still the US are on top, let's say 15 tons per capita per year. China is well below 6.4, Italy is 5.4, and so on and so forth. So the question is, should we, human race has a budget, we have to restrain the amount of CO2 emitted by burning fossil fuel. How can we find an agreement? And the discussion between the total per nation and the per capita is a big deadlock. There is no general agreement. Let me quote just a few weeks ago, let's say COP28. Let me quote, COP28 president says there is no science behind demand for phase out of fossil fuel. So from one side, we are trying to keep as much as possible low and to phase out burning fossil fuel. On the other hand, the projection of just oil, this is just oil, are increasing from now to 2050. So you can see there is no real agreement on how can we handle this big problem. In this picture, you can see, I'm not going to enter in the details because they are scary anyway. You can see if we go from +1 to +1.5, 2, 3, 4, and so on. So disaster can occur from an environmental point of view. But generally speaking, we can say that today you can find two different attitudes in people, from common people, scientists, many different communities. From one side, there is a group with an attitude that is going to say, okay, we have absolutely to stop at +2 degrees, because beyond 2 degrees, anything can happen from an environmental point of view, or so stick on the budget, or generally the idea from another group is, okay, there is no way we can do it, so we just have to learn how to adapt and to be resilient with respect to this enormous change in our environmental condition. You can choose yours, but generally speaking, we can say that today there are these two very different positions. Okay, now let's go to the mobility. Mobility is responsible for a significant part of the CO2 emission. I'm going to focus on the car-based personal mobility model. I'm not going to talk about train or airplanes and so on. Let me stick on cars. And in a bit of a bold way, let me say that the mistake number one, it's a mistake in retrospect. So after 1 billion cars on the planet, is the personal ownership. So in retrospect, it's a mistake. It was a mistake in the car-based mobility model. You can see the density of the car, the congestion. So these are the more developed countries. This is the number of cars per 1,000 inhabitants. You can see United States is on the top, almost 1-to-1 ratio. One person, one car, including babies and, let's say, very old people. Italy, focus on Italy. Italy, 60 million people, 45 million of cars. So a huge number of cars, really huge number of cars. As a consequence, obvious consequence, these cars are not significantly used. You can see here, this is the European Union focus. This is the average on EU. Let me drill down on Italy. 12,000 kilometers per year a few years ago, but today is the same situation. A bit more than 8,000 kilometers per year. 8,000 kilometers per year average is a really small amount of kilometers of mileage per year. So a huge number of cars not used. You can see here a different way to say the same thing, is the same statement. We recently analyzed a lot of data from telematic boxes. From this picture, you can see that, for instance, 85% of the cars in Italy are used less than 5% of time. So really a tiny amount of usage. And this is the focus on Milano. Half of the car stay parked on the streets. So a massive occupation of space, of public space in the cities. Let me make a comment linking this problem with the electrification. You know that today there seems to be, especially at European level, a big push towards a quick electrification with the idea that every people should change as soon as possible his, her car, let's say internal combustion engine car, into an electric car. Simple, bold statement I dare to say is that electric car and personal ownership is a significant mismatch. Let me explain a very simple way. So people today have an expectation of 400-500 kilometers range or autonomy of an electric car, but keep in mind that a lithium battery can be fully recharged, so full cycle, let's say recharging cycle of a minimum of 1,200 cycles, but more likely is 1,500 cycles. So it means that if you want this range, you get a lifetime of 600,000 kilometers. Now, compare this number with the average mileage of personal cars, and it's clear that there is a total mismatch. So the battery pack, which is by far the most expensive, the most, let's say, natural resources demanding. We need lithium, we need cobalt, we need a lot of stuff to build these huge batteries, is doomed to be not used or really used in a very small fraction of its potential. Let me anticipate a couple of objections I typically get. Objection number one, so don't worry because of this, let's say, huge capacity of the battery pack. We can solve it with vehicle-to-grid, private car as an accumulator for distributed generation. This is the picture. So a big personal car battery can be used as a local battery accumulator for micro-generated renewable energy. This is the picture, the small house, photovoltaic panels, and grid-to-vehicle, vehicle-to-grid. Nice picture. In practice, why using a sophisticated battery technology designed for mobile application for local storage? Carrying around a big battery, which is used just 5% of the time, is a good idea. And how many households can apply these concepts? So this is not the picture we see in our cities. We are more and more people are going to vertical cities, not in environment like this. The second objection is that, okay, we don't have to go into the electrification in the sense of battery pack, but into the e-fuel path. I don't know if you know what is e-fuel. It's very simple, let's say potentially brilliant technology. The idea is that you start from renewable energy, let's say photovoltaic, let's say wind, whatever you like. Electrolysis, hydrogen. Hydrogen is very difficult to handle. You don't stop here, and then you capture CO2. You make hydrogen heavier and heavier by adding carbon until you get the e-diesel or e-gasoline. Fantastic, because you don't have to change the technology. You just put e-fuel in your, let's say, today gasoline or diesel car. Nice. Unfortunately, the electric energy two-wheel efficiency is extremely low. I say much less than 10%, but it's a really small number. So overall, we can say that there is general agreement that the electrification with battery pack is the way. So e-fuel cannot really solve the problem unless the electricity, renewable electricity, is going to be extremely low cost, extremely easy to get. So, cross-links. Two main trends, from fossil fuel to electric, from personal to shared. Let me introduce the share concept, so the car sharing concept. So we have seen that, simply speaking, there is a big mismatch between personal and electric. Instead, there is a fantastic, a perfect fit between shared and electric, because shared means large mileage, globally optimized recharge, shorter trips, smaller vehicles, and so on and so forth. So it's a perfect fit between the shared and the electric. Why car sharing is not really used, did not really take off as a way of using as a mobility model? The typical, let's say, objection or comment I get is that cultural barrier. So people do like have their own car. This is true, but only for people my age and above. So in my generation, this is true. We are really, we suffer a lot on the idea of getting rid of my personal car and going to a sharing model. This is not true for group age below 30. So young people are very, from the young people point of view, it is very welcome, a new type of mobility model where the car is a service, is not a property. So there is no cultural barrier, especially for the future, for younger generation. What is the problem? The problem is a real problem, it's not a cultural problem. Consider that Milano today is one of the cities in the world with the best developed car sharing offer. So we have a lot of possibilities of car sharing, but still it's a very tiny niche. Why? It's very simple. If you want to give a high level of service, so if I'm here, I want to find immediately a car very close to me, just a few minute walk. If you want to give this level of service, you need a huge number of cars, but it means low mileage per car, which means high cost for the user or non-profit for the provider. It's a deadlock, and it's nearly impossible to get out of this deadlock. It's an intrinsic limit of this mobility model. It works somehow for big, very dense cities, but as long as you go in less dense cities, it's nearly impossible. What is the solution? The solution is quite simple and obvious. We need the autonomous car. We need the autonomous car at this point with a few cars. Even if you are here, you don't have to go to the car, but the car can come to you. It's a totally different level of service. So you can give a very high level of service with few cars, so high mileage per car, low cost and profits. And bingo. So the problem is actually solved. Notice that, I like to stress this point, that in principle can be done with a full robotaxi. This is a full robotaxi. It's very easy to visualize what is a robotaxi, but also much less is enough. What is really needed is that you bring autonomously the car from the parking place to you, and then when you can drive, it's not a big issue, so I can drive. I don't really need the Robo-driver when I'm on the car, but I want the Robo-driver to take care of the car when I take the car and when I leave the car. These are the really weak points of this mobility model. Let me show you a few numbers which are impressive in some sense. This is a simulation based on real data of how people in Milano move today. We take a radius of 10 kilometers, which is a very big radius, much bigger area than car sharing today. We took all the cars in Milano with 90% trips in, start inside the radius, the circle, and end the trip inside the circle. So these cars are perfectly ready to move from personal ownership to car sharing. And we simulate with real trips how can we manage this demand of trips with autonomous driving. Look at the numbers. 40,000 cars can be replaced with 4,000 cars. So the actual ratio is 11 to 1. You take away 11 cars and you replace with just one car. Average mileage, almost 50,000 kilometers per year, which is very good as an electric car, which is a good point. So we are really using that asset. Service level extremely high, 2 minutes of waiting time. So really high, let's say, level of service. The interesting point is that this model is scalable. We apply, you say, okay, Milano, okay, but Milano, there is one Milano in Italy, it's a very special city. Okay, let's try to apply on a more standard mid-sized city in Italy. There are plenty of them. This is the case of Padua. Again, 10 kilometers. Notice that 10 kilometers includes a lot of the neighborhoods, a lot of villages around Padua. Same story. The only difference is that instead of 11 to 1, we get a 8 to 1, but 8 to 1 is still a huge number. And the level of service is still very high. and the mileage is the same. So it's really highly scalable around not only big cities, but also on mid-sized cities. So, conclusions. So the final comment is that electrification is good, but we need to follow the right sequence of events and technologies, let's say the consecutio in Latin. So electrification with personal car should be limited to no more than 20%. This is what the data tells us. So there is a share of cars today that can be electrified by keeping personal ownership. It's a small share. It's something around 20%, no more than 20%. This is the sustainable electrification keeping the personal car model. Then we need the autonomous car. Autonomous car can really boost mobility as a service, so the car sharing as a mass market service, and then we can complete really the electrification. So in this sequence, it's clear that this is the enabling technology. I call it the big bang of this mobility revolution. Where are we? Let me focus on Europe, because, let's say, in other part of the world, the situation is slightly different. In Europe, essentially, we're still below level 3. So you can buy a level 2 autonomous car, but it's an ADAS. It's not really an autonomous car. Autonomous car is, so the autonomous robot-driver, let me stress, it's a massive technical problem, still to be fully solved. This is a conference related to robotics, and I'd like to highlight that among the many, let's say, robotizations of human tasks, so there are many, let's say, human tasks that has been made automatic or robotized. So the autonomous driving is one of the most complex. Let me call it the ultimate challenge of robotization. This is a list of hurdles you have to face. It's a massive combination of issues. High speed, complex and fast dynamics, high safety issues, humans on board, humans in dynamic obstacle, extremely variable environmental condition, high mapping uncertainties, massive localization issues, extreme multi-agent environment, which means hybrid robot-humans environment, which means gray zone in engagement rules. If you have to play robot and humans and engage each other, so the human is quite is unpredictable, and we made a soft gray interpretation of a lot of rules. Extreme variety of dynamic obstacles, extreme dynamic obstacle density, and so on and so forth. So it's a massive list of very difficult conditions. So let me conclude that other robotization domains here is really difficult to find. Of course, there are other robotization tasks which are very challenging, but it's difficult to find something which is as challenging as the autonomous driving. The next classical question at this point you probably have is when should we expect a full deployment of this technology? And my simple answer is typically nobody really know. Nobody really know, and I like to use this chart by McKinsey, which is a bit funny, but it's serious because this is the truth. Look at their prediction. This is a prediction of how many L3 or more cars will be on the market in 2035. It's a prediction. And the prediction is, we predict that can range from 10% to 95%. What a prediction. Okay, means nothing. So means it's unpredictable. I typically tell them, you can also say from 1 to 99, no big difference, and the conclusion is the same. Again, it's a bit funny from some point of view, but it's true. It's true because it depends on many items which are non-technical. From this point of view, let me use this sad example, because there was a victim, probably know, recently, few months ago, Bay Area, a cruise taxi hit a person and was a victim, and Cruise cut the fleet almost immediately by 50%, but the point is, could a human driver have avoided this person on the road? No. The statistics says that there are much less collisions of cruise robotaxi with respect to human-driven robotaxi. So it looks like a contradiction. A lot of aggressiveness of, let's say, of people against this technology, but the data tells that would be the opposite. Now, let me show you this small exercise. It's a very simple exercise. It's a simplification, but it's realistic. Now, I propose you two scenarios. Look at these two scenarios. Scenario number one, we introduce autonomous vehicles today, when today they're slightly safer, let's say 10% than humans. So today, roughly speaking, we can say that as is, autonomous car technology today is a bit better than average human driver. The second scenario is that we delay AV introduction until nearly perfect. We have to wait some time because we need still to develop until they are nearly perfect. Question: what is the best decision? If you are a policymaker, a decision maker, by far the right decision is this one. So just in the US, over 50 years, with this decision, you can save 500,000 lives. So you say it's no-brainer that the decision is this. Instead, especially in Western countries, Europe, US, and similar, the decision taken today is this one. So some comments, think about that. This is, for me, a very nice example when the good for the individual is playing against the good for all. Number one. Second question, are we ready to accept the error of technology? The answer is absolutely no. And the most critical question is, who will be the winner of AV technology? I don't say the name, you can imagine, but definitely will be the part of the world, the country, that will balance at best risk and opportunity. In our culture today is not a criticism. We are all in the same, let's say, we all have the same cultural attitude. If we have a victim, an accident from technology, we put a lot the media spot on that person. We say that's the mother of 3 children and so on, which is very sad. I'm not saying it's sad because we have a victim, we have a tragedy, we have a family tragedy. A lot of, let's say, spot is on that, but the 99 people saved don't have a face, they don't have a spot to be presented. So we super focus on the problem, we don't put the spot on the opportunity, on the saved people. And this is a cultural problem. This is a cultural problem. The outcome is that someone will take the lead. I'm talking from the Italian or European point of view, but because of an attitude of balance of risk and opportunity. Okay, let's see now, let's move to something nice. So if this revolution is going to happen, thanks to the autonomous car technology, this is the vision, let's say, the expectation we have for a bright future of our cities. So we would like to foresee, to have a long-term vision. This is why I'm working on this technology, because I like to think, to give a tiny contribution, but a contribution in the direction of this future. You see just a few cars, small, electric, fully autonomous, shared, and a lot of space, a lot of safe space for active mobility and, let's say, soft mobility, walking, cycling, and so on and so forth. So said, just a comment, it's a side comment. If we want to predict our society or our cities 30, 40 years from now, there is probably a second scenario, a second outcome, that goes into a fully different direction, so towards a full digital world. So from one side, we are still talking about physical mobility, but there is a massive push towards a more and more virtual mobility. And you can make your bet if in 30 years from now, 40 years from now, the world will be this, or we will see desert cities and all the people, let's say, indoor by virtual navigation. Final comment is that keep in mind that the more we have virtual mobility, the more there is a shift from this model, let's call it Uberization, mobility as a service, robotaxi, and Amazonization, which is goods mobility. So the more you stay indoor and you have virtual mobility, the more you increase the mobility of the goods, which is a clear trend, which is massively increasing. And so, from a technical point of view, we will need more and more goods transportation by electric vehicles and, most important, autonomous vehicles. This is an example. It's a mobile robot, just to exemplify what is expected in this trend of reduce human mobility and increase goods mobility. Let me close, then I have an appendix. Let me close my speech by a second comment about what I call the second mistake of the original mobility model. So, car-based personal mobility model. Mistake number 2, in retrospect, of course, is mixing fun and function. What I mean is that today, let's consider Europe, we have most of the cars are personal owned, and in our car, we definitely mix the function part and the fun part. Fun means, let's say, the appeal of driving a car, maybe in a bit sporty way, of owning the car. Let's say the emotional part of the story. In the future, at this point, it's easy to foresee a bifurcation. From one side, we will have the mobility as a service, or mobility on demand, so robotaxi-like model, 100% function. There is no fun, there is no emotion in getting a robotaxi, that's for sure. Don't forget the emotional part of driving, of having a car. So we should keep it because it's a need. It's a niche need, but it's a need. And we will see more and more emotional red vehicles, can be private or on service, not really fully autonomous because it doesn't make any sense. A fully autonomous Ferrari or Lamborghini or even sporty 500. It's a niche, it's an important niche, and today, honestly, this is probably the richest niche, the niche where you can make more market segmentation, because doing market segmentation in this environment is very difficult. You can make segmentation on the service, not on the car point of view. And today, the automotive industry is trying to move to position either in this point, which is very critical because it's expected a huge reduction of the number of cars, so it's not a good news for the incumbent automotive industries, or this, which is the premium emotional part of the story. Okay, now let me give just 5 minutes to end. Let me show off a bit, forgive me for that, a couple of projects, let me call them flagship projects, in the sense that not only they are a technical challenge, but they are quite interesting from what is called the public engagement point of view. Why I stress the public engagement? Because today there is the need to convince the general public that this technology is feasible, is safe, can change our lives in a better direction. So we need not only technology development, but also, let me say, public engagement. And these are 2 examples of where technology and communication stay together. They are sort of flagship projects. The first one is in the Autonomous Challenge. In the Autonomous Challenge has been the first example of autonomous motorsport. Don't enter in the details. It's not the place to enter in any details. I just want to say that the cars are identical in the sense that it's not a competition among cars, but it's a competition among robo-drivers with all driving exactly the same car with the same hardware, with the same electronics, and so on. The hardware is the same, the software, the brain, the algorithm is different. Some highlights. So the historical day for the birth of autonomous racing is probably January 2022, Las Vegas, CES. It was the first competition, fully autonomous, multi-agent, so a real head-to-head competition, and high speed, up to 280 kilometers per hour. The second highlight is 1 year later, again, Las Vegas. It's an oval circuit. At the moment, it is the best performing competition ever, so we really reach the limit of the potential of the car. So from the performance point of view, this is probably the best highlight of this series. Another highlight is the first competition of India Autonomous Challenge out of the US. It was in Monza in June 2023, and was also the first competition out of the oval circuits. It's a classical road course circuit, which is the famous Monza race. And the fourth one is the speed record. Speed record, I mean, is not the most difficult task for an autonomous car. It's very iconic. So we got this record on the really iconic landing facility of the space shuttle in Cape Canaveral. So today we are the holder of this almost 310 kilometers per hour speed record. The journey of autonomous racing is going on, so a new competition is almost born. It's called the Abu Dhabi Autonomous Racing League. Let's say it's very similar to the India Autonomous Challenge. The first competition will be in just a few weeks, April 27th, at Yas Marina circuit, and we will see what's going on. Let me say a few words about autonomous motorsport. Let me show you this chart. In this chart looks complicated, but indeed is very simple. You can see car driver, that can be human or AI, a Robo-driver. The car can be real or simulated, a simulator. And by combining all the possible combinations, you can get different race formats. The classical one, of course, is 2 humans, 2 real cars, easy. The classical gaming is 2 humans and 2 simulated cars. In the India Autonomous Challenge, we made first a simulation race, 2 AIs and 2 simulated cars, and the final race was this one, real cars, AI. Is this the future of autonomous motorsport? Most probably no. In the long run, probably is boring. The human factor is, there is a lot of human factor in the engineers, in the designers of this software, of this algorithm. There is no the hero. So most probably in the future, the evolution will be in this direction. So the ultimate goal with the highest complexity will be human versus AI on real cars. So real cars, 1 human, 1 AI, or many humans, many AI. Notice that it's interesting to see that in between, probably we will see this mix. So the human will drive the physical car, the AI will drive the simulated cars. To do this, we need a robotics technology, which is augmented reality in motion. Augmented reality in motion, so augmented reality glasses or helmet when you are on a car is still an underdeveloped technology. It's very difficult to provide augmented reality or mixed reality in motion. This is a research activity we are developing. So if you have this technology, you can actually mix a human with a physical car and AI with a simulated car, with a virtual car. In this way, you can really combine. If you don't have this technology, you can't do this mixed competition. The second flagship project we developed is much closer to the real application. Has been launched by Politecnico Milano a couple of years ago. It's called 1000 Miglia Autonomous Drive, or 1000 MED as an acronym. The general idea is to start making intensive development and experimental activity on road, on public road in Italy, and we choose as a reference path, as a reference journey, the famous, at least in Italy, it's very famous, 1000 Miglia. So Enzo Ferrari said the most wonderful race in the world. Okay. The 1000 Miglia is Brescia to Rome and back. Every year is a different road, but the idea is always is Brescia, Rome and back. Roughly is 1,000 miles. The goal of this experimental activity is to have a lot of high road diversity. There is a huge amount of different conditions. It's a reference journey with a lot of different conditions. This is very attractive from the development experimental point of view, and the long time extension, so positioning this point of the quadrant. The biggest challenge, honestly, it was the biggest challenge, so from my point of view so far, it's definitely the biggest achievement, was to get the authorization. In Europe, let me say a few words about this. In Europe, it's still extremely difficult to get authorization at nation level, so every nation has a slightly different rules. In Italy, we have some rules. Is this possible to ask for permission to make experimental activity? There is a decree issued in 2018. But just to give you an idea, it's 5 years we have this decree. We have been the second permission grant. It's not the 20th or the 200th permission grant, just the second, and by far for the highest number of kilometers. So it's nearly impossible. Nearly impossible. The bar is very high. We struggle a lot. We work a lot just to get the authorization, which was so far the biggest achievement and really the biggest hurdle, because you have to guarantee a lot of stuff altogether. Let me just show you a few pictures just to show off. We have been using this beautiful sport car. It's the brand new Maserati MC20 Cielo. You can see here the unveil and some spots, nice spots around Italy. This is Siena. This is Milano. We also, let's say, I've been working with a design group of Politecnico just to boost a bit, again, the public engagement and communication attractiveness of the project. We are going ahead. The idea is to go every year, to try to do a bit more every year. This is the 2024. We are going to use this, again, brand new electric car, is the Gran Cabrio Folgore of Maserati. The target for this year is try to get at least 500 kilometers of authorized roads where we can play on public roads, open roads to the public. So 1000 Miglia go through public, open. It's not a circuit, it's open road. This project is boosting a lot of side projects. You can see here a couple of pictures. The idea is to use this authorization platform to enlarge our capability of doing experiments on real open roads, and we are opening a lot of sub-projects much more focused on urban autonomous mobility, because the real goal we have is try to introduce as soon as possible this new mobility model. That's it, some conclusion. Let me just summarize the highlights of my presentation. Robo-driver will revolutionize the mobility model. I hope I tried, that I was able to sort of convince you that it's going to play a very important role. The Robo-driver will be the enabler of full-scale electrification. Looks like there is no interaction between the robotization and the electrification, but indeed the robotization will enable the electrification. They are not independent at all. Technology is still immature for large-scale deployment, pushing the limits. So, for instance, autonomous motorsport has the goal of pushing the limits, of testing the limits, and then go back to normal speeds. Will speed the development and acceptance process. Just a final remark, mostly focus on EU regulation. We need to speed up the testing and development in open roads of the Robo-driver. So we have to find, also from a cultural point of view and then from a political point of view, a much better compromise between risk and opportunity. Thanks for your attention.
Thanks a lot for the great presentation. I share your vision. The issue is, of course, the problem that you mentioned at the end. I think that Europe has intrinsically a big problem, that politicians do not want to take risk, and they do not see that without taking this risk, we'll stay behind the rest of the world. Do you see any way to change that? Because I think this is something that probably everybody would agree here, which is stopping our innovation completely.
We agree, and honestly, at the beginning, I was complaining a lot against our politicians. It's the most natural thing, but the point is that the behavior of our politicians just reflect the attitude of the people. So it's a cultural problem. So is there a way out? In my tiny contribution, it's a tiny contribution, but the way I'm trying to work is to show that this technology can work, focusing very much on specific use cases. My feeling is that if you can show in practice, not in San Francisco or in Phoenix or in Beijing, because it's too far for getting attention to the people and to the politician, if you can show that this can work, and you can show that a lot of mileage with no issues and so on and so forth, step by step, we can probably push our politicians to be more confident to introduce this technology. We need to keep, I'm talking again about European level, Italy in special of course, but European level, we have to keep absolute control of this technology. So again, today we are complaining a lot about the invasion of electric cars from China. It's a problem. That's an industrial problem, because the electric car is not really a major technology problem. It's a huge industrial problem. When we talk about AI driver, the robotization, the AI technology in the Robo-driver is a much, much bigger complexity technology, and losing control, losing the ability of keeping in Europe, in-house, the capability of developing and deploying this technology can be a massive risk for the future. Also from the safety point of view, for the, really from a geopolitical point of view, I believe it's going to be extremely critical, much, much more than the electrification. So let's try to do something together.
Hello. Thank you for the presentation. So I want to start with a critical comment from my perspective.
Oh, okay.
Yes.
Yep.
So even given that 99 imaginary people are being saved by autonomous cars, if a person that is near and dear to me is getting hit or injured, or I might sue that company in the end. And despite not wanting private properties, I don't want to lose my rights. And I think 20-year-olds will be 50 in 30 years. They will increase in appreciation for private properties. So given that the biggest problems are in cities, and why not localize an autonomous environment for cities, especially where you're only allowed to enter with an autonomous driving car, which the risk of having an accident is far lower, instead of doing a broad-scale country application.
Just to be sure that I got your comment. So your, let's say, comment and suggestion is to introduce autonomous on areas where only autonomous cars can work.
Areas where it's most attractive, like cities, okay, which would alleviate most of the issues you've talked about in your presentation.
Okay, so I mean, generally speaking, you're right. So consider that historically, this step was done. So historically, as far as I remember, Masdar City in Abu Dhabi, it's 2 by 2 kilometers square, let's say, built from scratch from the desert. So was designed to have internal mobility only with fully autonomous cars. So the idea is that inside this big square, you can use just autonomous car, no hybrid, autonomous and human. Nice, but practically speaking, especially in Europe, we have to overlay on our traditional layout of the cities. Of course, you can do it within an airport, within a campus, but you are not really impacting the general mobility. So the real challenge is to develop technology that can work in combination with human driver. The nice thing is that the more autonomous car we'll have, the less humans, so it will be exponential, let's say, the safety, because you are progressively pushing out the humans and getting in the autonomous vehicles, but I think there is no way. We have to deploy a technology that can work in combination with humans. Otherwise, it's going to be a niche. So, good idea, but it's going to be a niche.
Thank you for the very interesting presentation, but the sharing car have several weak points. For instance, we wake up at 7 o'clock and 1 million people want to go to the job. That is impossible to do using the sharing car. That it is the public transport, etc., is the better. That I think that it will be, but only in a niche if the global transport, because we must change the paradigm of work at several what we do each day.
I don't know what to say. I think 2 quick comments, but I mean, everyone can keep its own opinion, his or her opinion. Answer number 1. We are in a robotic forum. Robotization intrinsically take out a type of job, replacing with a different type of job. Do we agree on that? Otherwise, the robotization is going to be the killer of humanity, not the saver of the humanity. This is one of the examples where robotization shifts significantly the job from one side to another. But, I mean, you can agree or not. That's the point. My second point is, okay, let's be careful. I started with a very high-level statement. So as a humanity, we have a big problem. So we have to target that problem, because if you say, okay, that's not a big problem, let's try to save jobs or to keep the industry or so on and so forth, and you forget the big point, the big problem, I don't agree on that. From my point of view, that's a problem. We have to change also significantly our business model, industry models, and so on, in order to address that point. Otherwise, in 50 years from now, we will have plenty of jobs and a planet destroyed. So it's a matter of priorities. Let me use your comment, let me continue your comment by, I mean, I didn't stress in my presentation. Clearly, this revolution, as every revolution, has losers and winners. The losers are typically the incumbent, and the winners are the newcomers. This is history of any revolution, any technology revolution. So today, the incumbents are hiding a lot of the stuff I told you, because it's not their interest. Obviously, they play their game. The problem is that in this game, some stakeholders play in favor, some stakeholders play against. That's it. Obvious.
Fantastic talk. I've learned a lot. It's a quick question. I was wondering if, do you think there is a space for improving passive safety for especially the humans on the streets? And do you think this could help speeding up the adoption of autonomous cars, or there would be it would need too much time to be developed, and it's better just to change the perception of the risk?
A good question. I mean, passive safety for the obstacles like pedestrians, bicycles, and so on, I think requires too much of equipment, technology. Let me just give you a different type of answer. Good point. My feeling is that this revolution should happen, can happen, if the infrastructure requirement is low. Otherwise, if you raise the bar on the infrastructure requirement, like all the cars should be autonomous, all the cars should be smart road, fully equipped with that, we will never see the revolution. So the real challenge is to introduce the autonomous car like a human. It's a really robotization task. As a human, we are able to manage all the conditions. Are we able to replicate without any other, let's say, additional support this technology? That's the challenge.
Thank you.
Yeah, thank you very much for the very interesting talk. I do have a question. You mentioned the example of cruise, for example, and you said, I totally agree that we should do more testing, and this is critical technology, but I also see an additional risk, and that is that if we test too early because of the way our culture is, and we also jump at like the negative sides, that we kind of burn the technology in a sense that if we go too early, people will only see the risk. Do you have any ideas how we can mitigate that? Yeah, thank you.
That's a good comment. My point is that, let's say, we probably all know that in China, they are doing massive deployment of autonomous cars. My guess, it's a guess, I don't know, that there are going to be victims. It's obvious, because, so in Italy, just to give a number, in Italy we have 3,000 victims per year by stupid humans. What's the expectation of people? If people's expectation is that the AV technology should be introduced when instead of 3,000 we get 3, it's an over-expectation. So the reasonable point would be, okay, if AV technology can reduce from 3,000 to 1,000 or 500, that's a reasonable expectation. So in China, they're doing massive experimental activity. They are probably having victims. They don't go to Facebook every time they have an issue. I don't know, but I have no answer, but your comment is right. In our culture, you can burn this technology in this direction. You are right. It's a culture. We have a cultural problem.
Yep. Yeah, it's because I think because of the way we deal with probabilities, we don't do it rationally, kind of. Yeah, but thank you.
Hi, I have one question. You talked about autonomous cars and just cars, but what's the gap that has to be filled so that this technology can be applied, for example, to other vehicles like trucks or buses?
Well, there is no, in some sense, it's even, so if you go on a highway, on a restriction of the domain, which is the highway, which is the typical domain for, let's say, long-haul trucks, the technology requirement simplifies a bit. So, I mean, the technology we need is the same. So I'm talking about car because it's the largest amount of vehicles and the most complicated one. But
so this technology could be used, for example, to employ in the problem of public transportation.
Yes, but a comment. So if you just replace bus drivers with robo-drivers, you're not revolutionizing the model. My point was, if we can give a robo-driver to cars, we can really make a breakthrough in the mobility model. Notice that in the mobility model of share cars, almost all the cars become a public transportation. So public transportation will be, yes, it's public transportation. A public transportation, very modular, on demand, where you will have the big bus, mid-size bus, van, minivan, car, mini car, but they're all the same.
Okay. So I think it's time to close. There has been quite an interest. I think we really, everybody enjoyed, and thank you so much.